All right, welcome everyone. Today we are looking at the last section of our chapter. We're looking at matched pairs. And so the parameter that we're concentrating on here is known as the mean difference. And the way that you write that is, let me get this pen here. That's how you write it. It's the mean difference. That's the parameter we're looking at in this section. And when we talk about matched pairs, that means that you're looking at the same group. It's in a before situation and an after situation. So if you're looking to see if a particular weight loss program is effective in helping people lose weight, then you weigh the participants before they start the program, and then you weigh the participants after they start the program. And so it's the same participants, but it's the before and the after information that we're looking at. And so what we're going to do is we're going to calculate the differences and look at the differences. So I'm testing a claim. I'm going to be testing a claim about the mean difference. And the mean difference is, the notation is mu d. Now the previous section we were looking at the mean, but it was from two different groups. All right, so let me remind you that in section 9.3, we were looking at the mean difference, but it was from two separate groups. So it's the mean of the first group minus the mean of the second group. And that's because we had two independent. We had two independent samples, and one sample came from one population and the other sample came from another population. So we're looking at two different groups. But for this section, we're looking at the same group, and that's where we look at it as matched pairs. It's the before and the after situation. Okay, and so what I went ahead and I copied over to the whiteboard from the desktop was the formulas for Chapter 9. And let me just remind you where those formulas are. If you go to, right now you should see the My Stat Lab. If you go to Announcements and you scroll to the very bottom, you'll see the study guide. At the bottom here where you have your midterm and final exam reviews, there's the study guide on here. So if you click on that and you scroll all the way to the bottom, you'll see the Chapter 9 summary. All right, and so this Chapter 9 summary, it has all of the formulas for you. It gives you the calculator commands. And I break it apart. It's hypothesis testing first, because it'll say test the claim. So that's hypothesis testing. And then if you scroll down, it has confidence intervals. So you're constructing confidence intervals. And you have the corresponding calculator commands on here as well. So this is what I'm going to be referring to. Just everything is condensed, and so it's easier just to look at the different formulas as we move through this. All right, so that is what you see here on the whiteboard. Okay, so let me just remind you that we were looking at proportions back in section 9.2, two independent means. That's section 9.3. And so right now we're looking at matched pairs, and that's our section 9.4. So we're looking at matched pairs, we're testing claims, and we're going to be constructing confidence intervals. So when you look at the other set, it's the same thing. We have proportions, which is 9.2 for confidence intervals, and then 9.3 is two independent means, or two means with independent samples, and then 9.4 is what we're doing today, which is the matched pairs. Okay, so here are requirements. The sample data has to consist of matched pairs. That means you have the same group, and you have before and then you have after data for that, for each individual in your group. The samples are simple random samples. and either or both of these conditions is satisfied. So we need the number of matched pairs of sample data. If they are large, that means if they're greater than 30, then the population does not have to be normally distributed, right? So same as before, if your sample size is smaller than 30, then your population has to be normally distributed. Okay, so the number of matched pairs of sample data is large. If it's greater than 30, you're fine. It doesn't matter what's happening in the population. Or you need to make sure that the population comes from a distribution that's approximately normal. If that's the case, then it's okay for n to be smaller than 30. So it's still those conditions that we've been talking about. Again, if your population is normally distributed, then you're okay to work with any sample size. But if your population is not normally distributed, then your n has to be greater than 30. And this is our notation for matched pairs. What we're looking at are the differences in the before and the after data. So again, we are going to have data that's taken before and then data that's taken after. So the differences is the before minus the after. All right, so the before is usually given to you as x and the after is y. And so your difference is going to be x minus y. That's how you're going to calculate your differences. You're going to take x minus y, which is your before minus the after. Now, in your population, the parameter is mu with a little d next to it. Right? That's the mean difference. That's the parameter in your population. And then we have the sample means. D bar, that's your sample mean. And that's the sample mean for your differences. If you have D bar, that's a sample mean for your differences. All right, so we're paying attention to the differences. And so when we're looking at the differences, we're calculating the mean of the differences and the standard deviation of the differences. So the mean and the standard deviation of the differences is what we're focusing on. N is the number of paired data. All right, so you have to get used to the notation in this section. It's a little bit different than before. Okay, let's see what else we have here. When we're doing hypothesis testing, this is the test statistic that you're going to use. Now remember that anytime you use a test statistic, you're always working under the assumption that the null hypothesis is true. So when I look at the null hypothesis, the parameter in my null hypothesis is going to be the mean difference, the one that looks like that. And you're always comparing it to 0. So either there is a difference or there's no difference. And so we have the null and then we have the alternative hypothesis. And for the alternative hypothesis, the options is that it's not equal to 0, or maybe that it's greater than 0, or that it's less than 0. Those are your options. Okay, so if we're always working under the assumption that the null hypothesis is true, then the value of the mean difference is equal to 0 in your test statistic. So that part of the formula is 0. Okay, so you're going to use that formula to calculate a test statistic. And that's our formula for calculating a confidence interval. So notice that it's going to be for the mean difference. And in matched pairs, the parameter we're looking at is mu with the d, really, with the subscript of d. And the mean of the differences, that's our d bar. The mean of our differences, that's our d bar. And the standard deviation of our differences, that's SD. So keep in mind that once we look at our before and our after data, we have to make sure we calculate the differences. It's the differences what we're going to be using to construct the confidence interval if we're doing a confidence interval, or a test statistic if we're testing a claim. But we have to pay attention to the differences. Okay, so here's an example. And so notice that the way that this information's been given to you, it clearly tells you what the before data is and what the after data is. So I'll call the before data X and the after data Y. So we have a nutritionist and a nutritionist claims that a particular exercise program will help participants lose weight after 1 month. The table that you have here shows the weights of 6 adults. So that's your first adult, your second, third, fourth, fifth, and sixth. So each column represents 1 adult. And so you have the weights before the program and after the program. But your total sample here is 6. That's how many paired data you have. So N equals 6. All right, the next thing I need to do here, it says at a 0.05 significance level, so that means alpha is actually 0.1, it says. At a 0.10 significance level, can you conclude that the exercise program helps participants lose weight? Okay. So I have to calculate the difference. So I'm going to go ahead and put D here. So remember the differences, that's X minus Y. So I'm going to construct a table here. And at the bottom, I'm going to go ahead and put my differences. So for the first one, I should have used straight lines here. And while I'm drawing this, you can actually do the subtraction yourself and come up with the differences. So you already know what X and Y are, so go ahead and find out what D. Go ahead and fill out that row from our differences. All right, and as you're doing that, I just remembered that the lecture problems that I assigned for you, I forgot to give you several tries on that. I always give you several tries. So let's see, limit number of attempts, limit number of times students can work on each question. So I forgot to say that. I didn't have anything, so you are only going to get 1 try on that. So I just remembered I had to change that. Okay, so it took me a while to come back. Okay, so then, all right, so you have some differences there for us, good. So we have 7, -4, 0, 19, 2, and is that a positive 8 or a negative 8? Okay, good. So we have, so let's thank you for calculating that out. Let me copy it down. So these are your differences. And again, it's just by taking X minus Y. So if you take the before minus the after, that's how you come up with these numbers. All right, so what we're going to focus on are the differences. So we're going to use the differences from this sample to make a prediction about what's happening in our population for all people who use this particular exercise program. All right, so before moving on, let me go ahead and focus on this part of the problem. It says, test the claim that the exercise program helped participants lose weight. So it's helping participants lose weight. So I have to try to write that in a symbolic form. So helping them lose weight. Okay, so let's go ahead and see what happens in our sample. What happens to those who actually lose weight? What kind of difference do they get? So it looks like this individual went from 157 to 150. So did this first individual lose weight? What do you think? And do you see that when they lose weight, look at the difference. The difference seems to be positive, right? Let's go to another one. Here's another individual who went from 251 to 232. So definitely this individual lost weight from 251 to 232. So look what happened to the difference. When your before number is larger than your after number, your differences are going to be positive. So if there was any weight loss in this program, you'll notice that the differences are all positive. When there's weight loss, the differences are all positive. So this individual went from 140 to 138. So they lost weight. So the difference is positive when you do X minus Y. And this is very important to notice. Okay, if you want to go back and see what happened when people lost weight, what happened to the differences? All right, so when there was weight lost, so when there was weight loss, we had a difference that was positive. So then when we talk about a claim, I have to talk about the parameters, which is the mean difference. And remember that I'm always comparing it to 0. Those are the only options. In this section, you're only comparing it to 0. Either there is a difference or there's not. So in this case, if there is, so there's the exercise program is either going to help them lose weight or it's not. So the differences are either going to be greater than 0, less than 0, or equal to 0. Those are the only possibilities. So either positive, negative, or equal to 0. If it's equal to 0, then there's no weight loss whatsoever. All right, so test the claim that the exercise program helps participants lose weight. Notice that the participants who lose weight have a positive difference. So that's why I have to use the greater than symbol. So the parameter that we're looking at is greater than 0. So if it's greater than 0, that represents the individuals who lose weight. Because of our definition for our D, which is our differences, we say X minus Y. So that's the very first, this is very important to keep track of. What is our claim? Okay, so again, the differences that are positive represents individuals who lost weight. So there's weight loss occurs when your differences are positive, and so the claim says that this exercise program helps participants lose weight, so then I have to use the greater than symbol, because that's when participants lose weight, is when they have positive differences. If they had negative differences, that looks like they gained weight. So from 165 to 169, that's a negative difference. So they lost, or they gained weight. So those who have negative differences, they gained weight. And then those who had a difference of 0, there's no weight gained or lost. There's no weight gained or lost. So if your difference is 0, nothing happened. Okay, so I am going to go through the process of hypothesis testing. And so there's a blank page for us. But I'm going to just copy this down, okay? All right, so then the first step is we set up our null and our alternate. And remember, in this section, the parameter that we're using is now the mean difference. So you want to make sure you have the right parameter there. The null hypothesis always has equality, and for this section, we're always comparing to 0. We're always comparing it to 0 because either our differences were greater than 0, equal to 0, or less than 0. Now the claim, I believe the claim from the previous page said that the mean difference was greater than 0 because the claim was that this program helps participants lose weight. So if they're losing weight, we noticed that the ones who lost weight had a positive difference. So then greater than 0, that's our claim. And because it has greater than, it goes in the alternate. So that's step 1. And that step 2 is our test statistic. Okay, so step 2 is our test statistic. Now I'm going to copy it down here so that you have it. So our test statistic is d bar, that's the mean of your differences, minus your mean difference. And then that gets divided by the standard deviation over the square root of n. Okay, so that is your test statistic. Remember, we said that this part of the test statistic is 0 because we're working under the assumption that the null hypothesis is true. And to calculate our test statistic, we are going to need the mean of our differences and the standard deviation of our differences. Now the differences here are at the bottom. We just calculated our differences from the before and the after data. So if we have a list of data values, how do I calculate the mean of those data values? I want to calculate the mean of my differences. So what would I do to calculate the mean of the data values that I have there? All right, so I see that you gave me 2 ways of doing that. So if you just have your data values, of course, to get the mean, you just add them all up and divide by the number that you have, which are 6. So you can find the mean of the differences by just adding it up and dividing by 6. But if you remember the command on your calculator, the 1-bar stats, you could enter your list of data values and then just do the 1-bar stats on that. Okay, so you have those 2 options. Of course, back in the early chapters 3, I think it was chapter 3, we went ahead and we put data values in our calculator, and we did use 1-bar stats. And that gave us our mean and our standard deviation. All right, so that's what I'm going to do. So I'm going to go over to the calculator. And there's so many ways to do this. So I'm just trying to keep it as simple as possible. I am going to move you over to the calculator. So right now you should see the calculator on the screen. I'm trying to clear everything. Okay, so the way that we enter our data in here, and remember the differences, that's what we want to enter. You can go to Stat, then you go to Edit. Now I already have information on here, so I'm going to go up and clear it, come back down, go over and clear it, come back down. So I already have information on there, I'm just clearing everything. right, so there are a couple of ways that you can enter your data in there. Now we already have the differences, so you could just enter the differences and be done with it. However, say that you had more data values than what I gave you, and you wanted the calculator to give you the differences. Well, for L1 you could enter the before values, and for L2 you could enter the after values. Okay, and then have the calculator give you the differences. And that would be an option. So that's what I'm going to do. For L1 I'm going to enter my before values, and then for L2 it's going to be the after values. So I have 157, 165, 150, 251, 140, 137. Remember, I just want to calculate the differences. I know we had already done that on the whiteboard, but I'm just going to show you how you could just type in your before and your after and have the calculator give you the differences. And this is helpful just because it's, you know, if you have more data values, and it might be easier. It's less opportunities for you to make a mistake. Okay, so for L2 we have 150, 169, 150, 232, 138, and 145. So again, I went ahead and I entered the after data values in for L2. And now I'm going to go over to the top here on L3. You have to make sure that L3 is highlighted. It has to be highlighted. So I went up to it until it looks like it's highlighted. And then I'm going to tell the calculator to subtract list 1 and list 2. So it's going to be second 1 minus second 2. So look at what happens. L3 is going to be L1 minus L2. So then it just does the calculation for me, and it subtracts before minus after. So if you notice, those are the values you gave me. That was, these were our differences. So L3 is where my differences are. And they're going to be in there as data. So now that I have my differences in there, I'm going to go to Stat, and I'm going to select T-Test. But before I leave this screen, I just want to remind you that if you just wanted to enter the differences because you had already calculated them by hand, then you could have just selected one of the lists and entered the differences that you had already calculated. So it's your choice. But what we are working on is we are only working on the differences. So at the very end here, you're focusing on the differences. And that's the list that I have here, the 7, -4, 0, 19, 2, and -8. That's what I'm focusing on. So if I go to Stat and then right arrow over to Tests, this one's going to be the T-Test. So if you look at T-Test, selected, now you have the choice. You either have stats or you have data. Remember, my differences, they were in one of the lists. That was L3. So I have data. So if you go back, press Enter, you have data. And so the first is the value in the null hypothesis, which is always going to be 0. So that stays as 0. The list, that's where your differences are. So my differences were in L3. And then we're going to leave the frequency for at 1. And the inequality in the alternate hypothesis, I believe that was greater than. So you want to make sure you select the greater than. And then over the word calculate, you're going to go ahead and press Enter. What this is going to do is going to give you your test statistic, and it's going to give you your p-value. So there is your test statistic, and there is the p-value. Okay, so I am going to copy that onto the whiteboard. So remember that using the calculator, and I'm going to make a note here that I use the calculator and I use the t-test. And when I used the t-test, I got a test statistic of 0.6. And I guess it rounds to 0.688 because remember t's are rounded to 3 places. So that's 0.688. That's our test statistic. Okay, so then the next step is our p-value. And also using the t-test, we have our p-value, which is equal to 0.26. And it looks like it's 1, 2 if we round to 2 places. So 0.2612. So from using the t-test, we have our test statistic and our p-value. And then you'd have to tell me what you used on the calculator to get the test statistic and the p-value. Okay, now I'm going to step back just for a moment because I did give you a formula here and then I didn't use it. So for this formula, if you were to use your formula, you have to come up with d-bar and standard deviation. And so that's when I was asking you, well, if you have the data, how can you find d-bar and the standard deviation? And so some of you said, well, you can just do one-bar stats. Okay, so let me show you how you'd come up with the mean and the standard deviation if you wanted to use your formula. So I'm going to go back to the calculator. So the calculator should be back up on your screen. And I'm just going to go back to Stat and then over to Edit. I'm just going to go ahead and look at my lists. So my data is in L3. That's where my differences are. So I want to find the mean and the standard deviation of my differences. So that would be a one-bar stat. One-bar stat on that. So you're going to select Stat and then right arrow over to Calc. Right arrow to Calc, and then you have one-bar stats as your option. So if you select that, and remember that your data was in L3, and then we don't have a frequency list, so you can just leave that blank. If you have the older calculator, you just have to type in one-bar stat and then type in L3, and then press Enter. Okay, so that is the mean of your differences and the standard deviation. Now, of course, the calculator doesn't give you d-bar. The calculator is not giving you d-bar. It's giving you x-bar. You just have to remember that that's really d-bar. All right, so if you do calculate your own mean and your own standard deviation, just remember that the calculator has it as x-bar, but that's your d-bar. So d-bar is 2.7 if I round. And then the standard deviation, that's going to be 9.5. So if you had to calculate a mean and a standard deviation, you can do a one-bar stats on your calculator. And my list was on L3. So we have the mean, and we have a standard deviation. Now, you just saw that I had to round these. So the test statistic that I get from my rounded mean and my rounded standard deviation is obviously not going to be as accurate as the test statistic that I ended up getting from doing that t-test. But if you are using the formula, that's what we would plug in. All right, so let me just go ahead and compare. So let me just copy this down. So d-bar from our calculator, again, that was 2.7. And standard deviation, that was 9.5. So if you were to find the mean and the standard deviation and use the formula, then you'd have 2.7 over the standard deviation divided by the square root of n. So go ahead and tell me what test statistic you would get there. All right, so what did I just do here? I put n instead of what n really is. So let me just go back and put in a 6 because that's what it was. All right, so you're going to put that in your calculator and tell me what you ended up with for t. So we have 0.696. Everybody else agrees with that? Yes, we got a confirmation on that? Okay, so 0.696. Okay, so do you see that your test statistic from using the data option on your calculator is different than if you use the formula? And again, the reason is because I had to use a rounded mean and a rounded standard deviation when I use the formula. Okay, so you have to be careful on when you come and take the final, if you're using the formula, you need to make sure you write it out and you tell me what the mean and the standard deviation are, and then tell me what test statistic you ended up with. But if you used your calculator, then you want to make sure that you write down the command, the calculator command, that gave you the test statistic. So here was the t-test. All right, so either way you decide to do it, just make sure you write it out on paper. Make sure you write it out, what you did. Okay, so then our last step here, where we found the p-value, so our last step is our conclusion. So do I reject the null hypothesis? Do I fail to reject the null hypothesis? Based on the p-value, what do I do? Well, remember the definition, and the definition was that if your p-value is less than or equal to alpha, you're going to reject the null hypothesis. That was from our definition. So I'm saying you are all typing fail to reject, right? Because our p-value is not less than alpha, which was 0.1, right? It is not less than alpha. 0.2612 is greater than alpha, which is 0.10. So yes, fail to reject. Fail to reject. So now we can go ahead and fill in our conclusion. Remember, for the conclusion, you're going to your formula card, and you're looking at the wording of the final conclusion. All right, so let me take you over to the whiteboard and show you what I'm talking about. So that's the final conclusions, right? That's the wording of our final conclusions. All right, so that's the first question it asks is, does the original claim contain the condition of equality? Well, I don't remember. Let's go back and see. Did our claim contain equality? No, it did not. Our claim, it was greater than 0 because they were talking about how the program was effective in helping people lose weight, and when the difference was 0, that's when people were losing weight. So that definitely did not have equality. So the answer would be no. Did we reject? So I think no, right? We did not reject. We failed to reject. So the conclusion that you're going to stick with is that there is not sufficient evidence to support the claim that this program helps participants lose weight. Right, so that is your conclusion. Okay, so I'm going to try to type that out. I know things get strange when I try to type it out, so I'm going to be careful not to try to do anything fancy. All right, so what I read is what I'm trying to type. There is not sufficient sample evidence to support the claim that, and then I have to go back and read what the claim was, support the claim that the exercise program helps participants lose weight. Okay, so there's not sufficient sample evidence to support the claim that the exercise program helps participants lose weight. And again, that was for the problem that you can see on your screen now, where we were focusing on the differences. You have your before and you have your after data, and so we focus on the difference to see if there this particular program is helping participants lose weight. So you can't just base it on what you see on your sample. You have to make sure you go through the appropriate hypothesis test to see if there's a significant difference, to see if what kind of generalization or what kind of conclusions you can make about your population that's occurring. So what is your inference on the population parameter? So in this case, the exercise program does not help participants lose weight. And the only thing I have here to warn you about is the fact that if you use the formula for your test statistic, and if you use your calculator for your test statistics will not match up. So you want to make sure you write down what it was that you did to come up with your test statistic. So you're going to have to play around with that on the homework. You can try using the calculator first. If it's not accepting your answer, then you definitely want to make sure you're using the formula. All right, so you're going to have to play around with that on the homework. I think you probably want to, it might go based on the formula first, but I don't remember. So you're going to have to just play around with that. Okay, so that's our first example. And then this is our second example where I'm taking the same information, but now I'm constructing a confidence interval. Now before I move to that example, I am going to, there's been some questions about these conclusions. And so what I would like to do right now is I'd like to send you that table. All right, so on your screen, you're going to have something pop up. Now this worked before. I'm going to see if it works. Try to see if I can send that to you. If I can't, I'll just go ahead and make sure that I put it on the lecture notes, because someone brought it to my attention that on the new tables you don't have that conclusion, although it isn't within the reading of your book. Okay, so I don't see the option here. So I will make sure to put that table on your notes. All right, so let me show you what I'm talking about. All right, so when you go to my Stat Lab under Lecture Notes, at the very top, where it says class notes to print out and follow along with my lecture, I am going to put the formula card up there, the one that I keep showing you. All right, so let me just put formula card. All right, so we saw it a minute ago. Here it is. All right, so you'll have access to it there. All right, so you see it right there. That's where the formula card will be. And so what happened was the new formula card that came with the new edition, it doesn't have the diagram for your wording of your final conclusions. And so the one that I've been using does. So if you click on formula card, that formula card that I keep showing you, that's what's going to pop up. And so you'll just have to scroll down. You'll have to just scroll down to the final wording of the, let's see, that's at the bottom, I think. There it is. So the top one says finding p-values, and the bottom diagram is wording of your final conclusion. Right, so I don't know if that helps. If it's I didn't know, that wasn't brought up to my attention until later, so I just remembered to put that on there. Okay. So just in case you think that'll be helpful, this you have under lecture notes now. All right, so there's the last example we're going to work on. It's this one, and I'm using the same information. I'm using the same data that I had in the previous example. But now I'm constructing a confidence interval. All right, so I'm constructing a confidence interval. And if you remember the formulas that I had been talking about, your confidence interval formula is already on there. So let me go ahead and bring that up so you can see what I'm talking about. That's what I put here at the very beginning of class. These are all my confidence interval formulas. And so if we're looking at matched pairs, and we're constructing a confidence interval for when we have matched pairs, then that's the formula that I use. Okay, and I also showed it to you on the actual PowerPoint. There's a slide where I also looked at it. That's the slide. Okay, so I'm using the same data. So I'm going to go ahead and just copy that down. I'm going to go ahead and write down my values for D. And if you remember, that was 7, -4, 0, 19, 2, and -8. Okay, those are my differences. And I'm constructing a confidence interval for that. So the formula looks like this. It's the mean difference. That's our parameter. And you take the sample mean, which is coming from your differences, minus the margin of error, and you take, again, the mean of your differences and add the margin of error. Now the formula for the margin of error says that we take the t-critical value and then multiply it by the standard deviation and put that over the square root of n. And n in this case is 6. But for right now, I'm just writing down the formula, so I'm just going to go ahead and put n. There we go. Okay, so we already had the mean for our differences. So remember, that's where we did the one-var stats. Okay, so I'm going to go ahead and use the formula, and then I'm going to show you how to get this on the calculator without the formula. So the mean difference and the standard deviation, that's what we had already done using the one-var stats command. So 2.7 for the mean of my differences and 9.5 for the standard deviation. All right, so it says a 95% confidence interval, and that's what's going to allow me to find out what my t-critical value is. All right, so remember what table you're going to go to find your t-critical value. So let's see, alpha is going to be 1 minus 0.95. So alpha is 0.05. So remember, anytime we're working with confidence intervals, we are always working with two tails. Any confidence interval that you construct is under the assumption you have two tails. So alpha is the area in two tails. If you divide alpha by 2, then you get the area in one tail. All right, so table A3, yes, not A2, but A3, correct. So T's are on table A3. So if you look at table A3, remember degrees of freedom here is n minus 1. So if n is 6, because we have 6 data values, we have 6 data values, so degrees of freedom is 5. So go to your table. And remember, area in two tails is 0.05 with 5 degrees of freedom. So area in two tails is 0.05 with 5 degrees of freedom. Area in two tails is 0.05 with 5 degrees of freedom. So do you guys agree with that? Okay, 2.571. So that's your critical value, and that's the critical value that's coming from table A3. So let me go and write that down. Okay, so 2.571, I think that's what we had said. And then you multiply that by the standard deviation, which by the way has been rounded to 9.5. So that mark right there is supposed to be multiply, and then divided by the square root of n, which is 6. So that will give you the margin of error. Now, if you do that, remember you're working with a rounded t-value, so or a rounded critical value t. So when you get your margin of error, it should be 9.97126, something like that. Okay, so that should be your margin of error. And again, you just take your critical value times the standard deviation and divide it by the square root of n. And what happens now is you can go ahead and put that in your formula, So we have d bar, and d bar is 2.7. So you're going to subtract the margin of error, and then you're going to add the margin of error. So the margin of error gets added on to the mean difference, which is 2.7. And then that will give you the confidence interval. So when you do that, let me know what you get for your confidence interval. You can type in the left and then the right side. Okay, so I have an answer here. And I didn't tell you how to round, so you got negative 7.27. I'll round to two places. And then 12.67. Okay, looks good. And I have confirmation right below. Yes? Okay, perfect. All right, so that is your confidence interval. So what you're looking at here is whether or not 0 is included. Okay, so it's a 95% confidence interval estimate for the population mean difference. And we want to know whether this exercise program is helpful or not to help participants lose weight. So is this exercise program helpful in helping participants lose weight? So you start asking yourself whether 0 is included or not. So our confidence interval goes from a negative number to a positive number. So is it possible that 0 is included in this confidence interval? So it is possible, right, that the mean difference can be equal to 0. That is a possibility because it's in the confidence interval. So since it's possible that the mean difference is equal to 0, that means then that there's going to be no change, right, in weight. If the difference is equal to 0, that means there's no change in the before and the after. So from this sample data, the inference that we're making about a population parameter is that there's going to be no difference. So this program is not helpful in helping participants lose weight. This exercise program will not help participants lose weight. All right, so this program will not be helpful. This program is not successful in helping participants lose weight. That is the conclusion that we make from the sample that we're given. And keep in mind that we're looking at the differences. So you have your before and your after, and from the before and the after, we're looking at the differences. I used the formula on this, but I could have just used the calculator. So let me show you how you could have constructed a confidence interval with just using your calculator. All right, so let me bring up that calculator again. The good thing is your data is already in here, so I'm going to clear my history so it all looks clean. So your data, remember, is already on here. So this time you're going to go to Stat, and then you're going to go over to Tests, and this time we're looking for the T interval. So there's the Z interval, so one more to see the T interval. Okay, I passed it. I was too impatient here and I pressed that button too many times. So there's T interval. That's what I wanted. And so I have data. My data's already in there. That was my differences. So it's in list 3. And the confidence level, I believe, was 95. So make sure if yours doesn't say 0.95, make sure you change it to 0.95. Okay, so then you're using the T interval with that data command on there. So when you go over the word calculate and press enter, well, there's your confidence interval. Now it's not the same as what we had when we used our formula, but it's close enough, right? And on the test, yes, you can use your calculator on the test. Yes, you can use it. So this is, so let me go ahead and move this over to the whiteboard so I can tell you when you can use your calculator, when you can't. All right, so here's the answer that we ended up getting with the formula. So with the calculator, what you would do, because you have to show me how you got your answer, you can't just write your answer. So you would say T interval. That is the command that you used. And then you're going to write down your confidence interval. And it went from negative 7.30 to 12.64. And then be prepared to interpret your answer. So aside from writing down what the interval is, the confidence interval, you should also know how to interpret your answer. So what does your answer mean? That's what we did over here. So you should be able to interpret your answer. Okay, so the question is, can we just use our calculators to come up with the confidence intervals or the test statistics or the p-values? And yes, you could just use your calculator. In fact, on the final, whenever possible, you want to use your calculator. You're only going to use the formulas if I under the instructions, if I tell you that you must use the formulas. Now, as you see throughout this chapter, I've been showing you how the formulas work, and then I've also been using the calculator. So you should make sure you can use those formulas. Make sure you're able to get the answer with the formulas in case that I ask you that on the final. But you should also know how to do it on your calculator. I can't tell you to use the formula on everything on the test because there's not going to be enough time for you to finish the final if I have you use the formula on everything. So I'm going to have to pick and choose which problems I'm going to ask you to use the formula on. And for those, then you have to make sure you show me your work using the formula in order to get credit. But if I do not tell you to use the formula, then you're going to use your calculator. Just make sure that you write down whatever command you used. So as you're working your homework, make sure you try to use the formula once or twice. And then once you know how to use it, feel free to use the calculator. That's going to speed up that homework. Make sure you don't take too long doing the homework. All right, does that answer the question? Are there any other questions related to what I just said? So whenever possible, use your calculator. Unless I have in the instructions to use the formula, then you'd be using the formula. Okay. So for today's problems, for today's lecture problems, let me take you back to my stat lab. All right, so as you're looking at the lecture questions or the homework, you're going to go to homework. And under homework, lecture 22 is on there. And I have two questions for you. Okay, so the first question, notice that there's the before and the after situation, so that should give you a clue as to how you're going to do the problem. So it says before and after, and then I ask you questions about that. All right, for the second problem, again, it's a before and after situation. All right, so if you have a before and after situation, you should know how to start the problem, because that's what we talked about today. All right, so you have those two questions, and you can go ahead and start working on it right now. I finished a little earlier than I thought. I don't have enough time to start the next chapter, but I will do that on the next time. I'll start the chapter 10. And I'm printing out the participants list. So you have enough time to just get these problems done before you log out. I'll stay here in case you have any questions. So next time you come to lecture, I will get the next chapter. I will begin the next chapter. And we should be back on track. All right, so I'll talk to you next time. I will stay logged on in case you have any questions, and then you can just type them out. All right? Okay, I'll talk to you next time.